4.4, slope and graphs of linear equations. So we're going to use standard MA 912, AR 2.4. So we're going to determine the slope of a line through 2 points. We're going to write linear equations in slope-intercept form and graph the equation. We're going to use slopes to determine whether lines are parallel, perpendicular, or neither. So something you need to remember is slope. Slope is known as your m. The equation is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is also known as the change in y over the change in x, also known as your rise over run, when x sub 1 and x does not equal x sub 2. So in example 1, it says finding the slope of a line through 2 points. So they gave us 2 ordered points, negative 2, 0, and 3, 1. So we're going to apply the slope formula. The first thing you need to do is label your ordered pairs. So this is x1, y1, x2, y2. Next, you're going to write your equation for slope. Slope is equal to y2 minus y1 over x2 minus x1. Now we are going to substitute in. When you replace the variables, make sure your numbers go in parentheses in case of a sign change. So we have 1 minus a 0 over 3 minus a minus 2. When we come to that point, we see here we get 1 minus 0 is a 1. 3, you get 3 minus means plus 2. So that's where the change happened. So then our slope is 1 over 5. Okay, so slope of a line, there's 4 possibilities for slope. You can have a positive slope, which means you are going from quadrant 3 to quadrant 1. Your graph is going in a positive direction. You're climbing the mountain. It could be a negative slope. You're going from quadrant 2 to quadrant 4. You're downhill skiing. You could be a 0 slope, which means you are running parallel to the x-axis. So you have a horizontal line. And then you can be an undefined slope, which means it's going through the x-axis but running parallel to the y-axis. So which means we have a vertical line. Slope-intercept form, that's the y equals mx plus b, where m is the slope and 0 comma b is the y-intercept. For example 3, we're going to use slope-intercept form. So they want us to sketch the graph of x minus 3y equal to negative 6. Write the equation in slope-intercept form. So they gave us an equation. So the first thing we're going to do is rewrite it to solve for y. So remember, think of this side of the left side of the equal sign as being New Jersey, the right side of the equal sign is New York, and you're crossing the bridge, so you must change signs. So first thing we're doing is subtract the x over. So we get negative 3y equals negative x minus 6. Then you're dividing every single piece by negative 3. So then you end up with y equals, negative makes it positive 1/3 with an x, negative makes it positive 6 divided by 3 is a 2. So here's our equation. Then you are going to identify your slope and your y-intercept. So our m is what's always attached to the x. So our slope is 1/3, which means we are going up 1 to the right 3. Our b value, which is our y-intercept, is a 2. So it's the ordered point 0, 2. So this is how we're starting our graph. You're going to plot a point at 2 on the y-line. And the slope says we're going to climb up 1 step and 3 to the right. So we're going to go up 1 and 3 to the right. Basically think of you're forming a triangle. And then you sketch your graph line. Make sure you put arrows on the end because the line is going to positive and negative infinity. Parallel lines and perpendicular lines. So something to remember, parallel lines are going to be 2 non-vertical lines that have the same slope. Slope 1 must equal slope 2. You can think of this, you're driving in a car on the road, going down the lanes, going in the same direction. There's 2 cars going in the same direction. You're running parallel to each other. Perpendicular lines. are two lines whose slopes are negative reciprocals of each other, which means slope 1, for example, was 1/2. Slope 2 is now going to be -2. So it was positive, two numbered positives, and you think of it as -2/1. I switched positions and flipped the sign. So think of when you're coming to an intersection that is perpendicular. Okay, example 5 and 6 want us to determine if they are parallel or perpendicular. So it says determine whether the pairs of lines are parallel, perpendicular, or neither. So they gave us two equations. Y is equal to -3x minus 2 and y equals 1/3 x plus 1. So most people would just go ahead and graph them to see what happens. The problem with that is that sometimes intersecting lines might not be perpendicular to it. You need to look at the slopes. So we're going to say that this is equation 1 has a slope value of -3. This is going to be equation 2 has a slope value of 1/3. So to know if they are parallel, perpendicular, or neither, we're going to compare them. Is slope 1 the same as slope 2? Well, -3 does not equal 1/3, so we're not parallel. The next one is slope 1 perpendicular to slope 2? So -3 times 1/3 results in an answer of -1. So that is perpendicular. So how do you know? It's when you do slope 1 times slope 2 results in an answer of -1, that is perpendicular lines. So let's look at the next one. On B it says y equals 1/2 x plus 1 and y equal to 1/2 x minus 1. So slope, equation 1 has a slope value of 1/2. Equation 2 has a slope value of 1/2. So when we compare slope 1, does it equal slope 2? 1/2 is the same as 1/2, so we are parallel.